looking at our first one, we have 3 over x. Odette, what does the first one need to make it 3 over x cubed?
X squared.
Yeah, so this one needs an x squared. That's the part that it's missing. Because x squared times x makes x cubed. So now the first term says 3x cubed. How about 3x squared? The denominator says x cubed. Odette, what's the middle one need? Just an x, because there is an x squared. So x squared and x make x cubed. So this whole quantity has to be multiplied by x. That gives us x squared plus 2x. Again, you multiply the numerator out so that we can then combine like terms. And then the last one has an x cubed, so it doesn't need any piece to make the common denominator because it is the same. And that just stays as x cubed plus 3. So we have 3 fractions. Julian.
In the problem, paper says it's x squared plus 3.
Not x cubed?
Yeah.
Yeah, thanks. So squared. So the last step then would be to combine all of the like terms in each numerator. So that would be looking to see at x squared terms. So right there we have 4x squared, but this minus sign is subtracting the x squared. So now we have 3x squared. Looking at any other terms, we have a 2x. And then this subtraction also goes with the 3, so there's a minus 3 on the top. And then that's over x cubed. So 3x squared plus 2x, and then that minus 3. Make sure you're carrying that negative through the entire numerator. So make sure you've got a minus 3 back there and not a plus 3. Any questions with number 7? So also looking at number 8, because number 8, you gotta make sure that you simplify it the whole way. So we have for number 8 a 2x with an x plus 1, a 3x with the x minus 1, and then a 6 with x squared minus 1. The first step to get a least common denominator is to make sure they're in factored form. Do any of these denominators need factor? Julian?
The third one is
Yeah, the third one. How would x squared minus 1 factor?
x plus 1 times x minus 1.
Right. So factor it first and make sure that you keep it in factored form. So Julian, what would the least common denominator be for those 3 fractions?
X plus 1, x minus 1.
Right, so looking at the 3 different pieces in the denominator, we have an x plus 1 and x minus 1. Here's an x minus 1. There's an x plus 1. So each factor that's different becomes part of the least common denominator, but there's actually only 2 different factors. So one of them is an x plus 1. The other one is the x minus 1. So we need to make sure we have that in each denominator. So Maddie, the first one has x plus 1. What does it mean? An x minus 1. If we multiply the numerator by x minus 1, what does that become? Nice. All right, Maddie, what's the middle one need? And the numerator becomes? And then the last one? Yeah, it just stays the same. It just gets a 6 because it has the least common denominator. So if the denominator is the same, then it's not going to change. It just stays as the 6. So again, we're going to combine all the like terms on the top, except this middle value has a minus sign. So we have to make sure that we're subtracting. So when you look at the top, Abby, what like terms do you see that we can combine together? Yeah, so 2x squared minus 3x squared, that gives you negative x squared. And then? Right, so in negative 2x, this minus goes to the 3x, so that makes? Negative 5x. And then the last piece is the 6. And it's a plus 6, there's a plus sign in front of it. So then in the denominator we have x plus 1 and x minus 1. So Be careful with that minus sign. It goes to the 3x squared, but it also goes to the 3x. So if you looked on the answer sheet, you would have seen that this was not the answer on the answer sheet. It's actually a little different. Is there anything you can do with the numerator of this fraction? We have negative x squared minus 6x, or minus 5x plus 6. Addie, what's one thing we can do with the numerator? Yeah, we can factor out a negative 1. So we have a negative x squared, so let's pull out a negative 1. So that makes a positive x squared, a positive 5x, and then a minus 6. And then x plus 1, x minus 1. Is there anything else we can do with the numerator? Julia? Yeah, you can factor it. If the numerator is factorable, that means that we can try and break it down in some way. And in this case, Julia, how does it factor?
It would be 6x and then minus 1x.
Yeah, so it would be a negative 6, how about a positive 6, and then a minus 1. So this factors, so we can actually break it down a little further. So we have a positive 6, because we want to make a 5, and a negative 1. So x plus 6, x minus 1. So if we factor the numerator, now if you look at the problem, it's all factored. We have pieces on the top that are factored, parts on the bottom that are factored. Julia, what can you do to simplify it?
You can take out the x minus 1 from the numerator.
Right. This x minus 1 can be taken out from the numerator and denominator because it's the same. When you're multiplying and you have the same quantity, meaning whatever's in parentheses is exactly the same, you can factor that piece out, and that's what happens with this one. So it doesn't happen all the time, every once in a while. The numerator is factorable, and when you factor it, there is a piece of the denominator that will cancel from factoring that. So if you were looking at the answer sheet, weren't sure really how that answer was created, it's because you could factor the numerator. And after you factor it, then you have quantities that are the same that can cancel. Again, it doesn't happen all the time. Every once in a while, the numerator can break down and then cancel with the denominator. But it's something to check. So make sure you're looking at your numerator. Is it factorable? Can it be broken down further? Questions? So today we're going to do some complex fractions. And then as I said, tomorrow we'll kind of finish any extra problems in the notes that we haven't gotten to. Try and do a couple of examples tomorrow on the common denominators and the complex fractions. So in your packet, you'll turn to section 8.5. This is still part of 8.5. 21. So at the very bottom of page 21. So the top of page 21 has independent practice problems. We'll probably review those tomorrow. But if you go to the bottom of page 21, it says simplifying complex fractions. So a complex fraction is a fraction that contains a fraction in its numerator or denominator, or both. So not only are we talking about having a fraction, but we're talking about having a fraction within a fraction. So numerically, if I have 1/2 divided by, we'll say 5/6. That's what a complex fraction is. So you're taking a fraction divided by another fraction. That's pretty much what you're doing. The fraction bar, the main fraction bar, that really means divide. So when you have a fraction and you have the fraction bar, you're really taking the top number divided by the bottom number. Well, in this case, we're taking a fraction divided by another fraction, and that's called a complex fraction, once you have a fraction inside of it. There are two different ways that we can simplify complex fractions, and it kind of depends on what problem you're given and the method you'll use. So the first one says, if necessary, simplify the numerator and denominator by finding the least common denominator And then we'll either be adding or subtracting. Just abbreviate there. It's a short little line. So generally, we use method 1 if we don't have to find the least common denominator. So if I have one fraction divided by another fraction, we usually use method 1. And I'll show you what that looks like. It says then divide the numerator by the denominator. The second step will multiply the numerator and the denominator by the least common denominator of every fraction in the numerator and denominator, and then simplify. That's pretty wordy. So we're going to look at the entire fraction. We're going to look at all of the denominators. So really, we have a denominator on the top. We'll have a denominator on the bottom. So we're going to look at the separate fractions. We'll determine what the least common denominator is of all of the fractions in the problem. And then we'll multiply the entire problem by that. So that would be the second method that we'll use. So if you look at the first problem, it says that this one is method number 1. So the top, we have 8 divided by 5x. The bottom, we have x plus 1 over 15 plus 4 over 15. So we would want to use method number 1 because you don't really have to find a common denominator. It already has a 15 in the denominator, so we would first add those pieces together. So I'm going to keep the 8 over 5x. So we'll combine the denominator part, those two fractions in the denominator. They have a 15 on the bottom, so we'll combine them together. That's the simplifying part. So Connor, if we combine the denominator's fractions together, what does that give us? X plus 5, and then over 15. So right now we have one fraction on the top and another fraction on the bottom. And this line here really means divide. Last Wednesday, for section 8.4, we talked about dividing fractions. How do you actually divide fractions? Julian? Yeah, you multiply by the reciprocal of whatever follows the division sign. Well, that means whatever is underneath the division bar is the part that we're multiplying by the reciprocal. So we're going to totally change the way this problem is written. We're going to keep the 8 over 5x. This is my division sign. So division gets changed to multiplication. So now it's multiplication. And then we're multiplying by the reciprocal of whatever follows the division sign. Well, that's this piece here. So we're going to take the reciprocal of that piece, which means flip it over. And now it's a multiplication problem. Because division is the inverse of multiplication. So I can take a problem that was division and change it to multiplication by taking the reciprocal of whatever's after it. And then it said to simplify. So is there any way that we can simplify this? Before we actually do the multiplication, can we simplify it? Would that? Yeah, you're allowed to cross cancel. So looking at the numerator of the right, the denominator of the left, we can reduce those numbers. So 5 becomes 1, 15 becomes 3. So we're cross canceling. You're reducing those numbers before you actually do the multiplication. And now whatever is left, you're looking across the numerator. So we have 8 times 3, which gives us 24. And then in the denominator, I'm actually going to leave this in factored form. So there's an x of the first denominator, the x plus 5 of the second denominator. I'm just going to leave them as a separate quantity because something that's factored is considered simplified. So in all the problems that we worked with all year, we've been factoring them to try and break them down. That's a method of breaking something down or simplifying it. So this would be our final answer. As long as that 24 can't reduce with anything underneath it, then it's simplified. Questions? So that was method 1 with using a complex fraction. So we're really taking the top and dividing it by using the reciprocal of the denominator. So if you look at this second one, flipping over the next page, this one says to also simplify a complex fraction, but it says to use method number 2. The method number 2 was to look at all of the denominators and try and find the least common denominator of every part of the fraction. So we're looking at the 3x, the x minus 1, and also the x minus 1. So we have 3 denominators. What would the least common denominator be of all of the denominators? Julia?
3x, x plus 1.
Right, so we're using all 3 of them, and our least common denominator, she said, was a 3x, because the one on the left here has a 3x, and then the other 2 both have an x plus 1. So that's our least common denominator. So when you have a fraction, you are allowed to do anything to the fraction as long as you do the same thing to the top of the fraction and the same thing to the bottom. This line here is our main division line. So I'm allowed to do anything to the top as long as I do that same thing to the bottom. So we're going to take the top part and multiply it by whatever it needs for the least common denominator. So we're going to use this least common denominator and multiply this by whatever extra the denominator needs. So we're still using a least common denominator, but we're using it like as separate pieces in the fraction. So currently, this has an x plus 1. Melanie, what would that need to make it have the least common denominator of 3x times x plus 1? Yeah, we need to multiply it by 3x. So the bottom needs multiplied by 3x, and the top needs multiplied by 3x. So Melanie, what would the top of that fraction become?
6x squared.
Perfect, so 6x squared. The bottom is now 3x times x plus 1. Again, keep that in factored form. So you multiply the numerator, but the denominator is remaining as a factor. So we're just getting a least common denominator for that part. So then looking at the one on the bottom left, Melanie, currently it has a 3x. What does it need for its least common denominator?
X plus 1.
Right, it needs an x plus 1. So we need an x plus 1. There's just a 1 up there, so that's going to become x plus 1. And then it has a 3x. Now it has x plus 1. All right, there's a third fraction, and Melanie, that third fraction has an x plus 1, so it needs
3x.
a 3x. And that numerator is 2 times 3x, so that's 6x. And then on the bottom, 3x times x plus 1. So we got a least common denominator for all 3 fractions, which was really like the last couple of problems that you had on the homework. It's just you were subtracting all of them. So we're going to see if we can simplify any of this if possible. And that would be looking at the denominator here because there's a plus sign in our denominator. And I have one fraction that has a common value as the second. Adding means we need to combine them together. So the top is going to stay the same, 6x squared divided by 3x, x plus 1. Will, if we add the bottom together, what does that mean? We're just adding these pieces here.
7x plus 1.
Right, 7x plus 1, and then 3x, x plus 1. So again, this is like getting a common denominator, adding fractions, subtracting fractions. So what do you think happens with this problem now? Odette?
Well, if you were to write it with multiplication when both denominators end up canceling, so it would be the numerator of the one over the numerator of the second.
Exactly. So because we've got the common denominator for the whole entire fraction, the bottoms are the same. So she said if you'd write it as a fraction or as multiplication, they would end up canceling. So if your denominators are exactly the same, then they cancel because they're going to cancel each other out if I change it to a multiplication problem. So this denominator now cancels with that denominator because they are exactly the same. And we're left with 6x squared divided by 7x plus 1. So it's a little bit of work to get there because you're using this least common denominator in all of these separate fractions. But then once you have the denominator and it's the same, they literally cancel because the top is identical to the bottom. And you just have then the 6x squared and the 7x plus 1 remaining. Okay. Questions? So if you look, there's a couple examples down below. We'll kind of do a couple to try and look at each type of problem. So looking at number 1, we have 6x over 4 minus x over 4, and then we have 8 over 2 plus 3x over 2. So this would be method number 1, because the denominators are already the same on the top, they're the same on the bottom. So we can just subtract the numerator. So 6x minus x gives us 5x. 8 plus 3x is just going to stay as 8 plus 3x, and then divided by 2. So the denominators are already common. You don't need to do anything different, just combine the top together, combine the bottom together. And then division is really multiplying by the reciprocal. So keep the top the same. Multiply by the reciprocal of the denominator. This line is really our division bar, so whatever follows it, we're taking the reciprocal of. So now this is 2 on the top, 8 plus 3x on the bottom. And then simplify if possible. Here, is there any way you can simplify this?
2 can be simplified to 1, and the 4 can be simplified to
And then what do you have left on the top?
5x over 3x plus 8.
And then there's a 2 on the other fraction. So 5x, and then divided by 2 times 3x plus 8. Questions? So let's look at number 2. This one, the denominators are not the same, so I can't just combine them together. So we can use method number 2, where we're going to look at what the least common denominator is for all the fractions. So look at the bottom of the fractions. We have a 2x, an x squared. We have an x squared, a 2x. What would the least common denominator be? Bill, do you have an idea what the least common denominator would be?
2x.
Yeah. So our least common denominator would be 2x squared. So we're going to make all of the denominators have that 2x squared in it. So the first one has a 2x, but it needs another x, so that becomes a 5x. The second one has an x squared, but it needs a 2, so that becomes a 14. So whatever piece it's missing to get the common denominator. On the bottom, again we have an x squared, but it needs to be 2x squared, so that 3 needs to be multiplied by 2. And then you're subtracting a 2x, which needs another x, so we would really be subtracting a 1x. So Emma, what do we have on the top?
5x plus 14.
And then on the bottom,
6 minus x.
she said 6 minus x. So the denominators are the same, they literally cancel because they're identical. So I have the same thing on the top, the same thing on the bottom. And we're just left with that 5x plus 14 and the 6 minus x. Questions? So see if you can do that last problem. 2 over x plus 3 plus 1 over x. 3 over x plus 3 minus 2 over x. So think about that least common denominator of all of the fractions. What's the least common denominator? just because the one has an x plus 3, the other one has an x, those are different x's. So our least common denominator has to have the single x and then the x plus 3. So Mackenzie Mallory, what'd you get on your numerator?
2x over x plus 3 plus 3x over x times x plus 3 divided by 3x over x times x plus 3 minus 6x over x times x plus 3.
What did you use as your least common denominator? Yeah, that's right. I think you just have your x terms flip-flopped. Just look at your multiplying. So I think you said you have 6x here? Yeah, so check that, the 2 times the x plus 3. So in your numerator, we should have a 2x plus x, and then the 3. On the bottom, we have a 3x minus 2x, so that's an x. Don't forget that minus goes to the 6 as well. That's the hardest thing to remember. So that should be an x minus 6. So my denominator cancels. The numerator here has a 3 in common, so I would pull out that 3, make it simplified, and then the denominator has the x minus 6. Questions? So you should have a complex fractions worksheet that was passed out to you. On the front of that worksheet, there are 9 complex fraction problems, and then on the back, there are 3 problems that are continuing to review combining fractions, adding and subtracting fractions together. I will send out the answers through Remind, post them to Google Classroom for you, and then tomorrow we'll kind of just like wrap up the adding, subtracting, complex fractions part, and I think there's a little bit of multiplying and dividing review as well, before we move on to solving the equations.